At the moment, P is a subject of the formula, so it's set up to find P, so P is a subject. To be able to find P, and actually this is a general point for formula, because often in an engineering scenario, you've got lots of formulae. You have tables and books full of formulae. Obviously, if you do a lot of work with mechanical engineering, then there's certain key formulae that you tend to come back to and over again. But there may be a few formulae that you could use to find the pressure, depending on what you're given and what you know. So the first thing to do is to identify the formula that you need to use. If I want to find the pressure using this formula, I need these three things: the depth, the density, and g, the acceleration due to gravity. If I don't know any of those three things, for example, if I didn't know that the density, what the density was, I might end up having to use another formula to find the density, which you've seen already is the mass over volume. So I might have to do a preliminary calculation to find the density, given the mass and the volume. Once I know the density, I can then plug that into here to find the pressure. So that's the sort of thing you need to do as an engineer. Note different symbols are used for different things, for different formulas. So D for density, rho for density. You will see that. So don't let it confuse you. Unfortunately, engineers are not consistent. They use different symbols. Different people use different symbols. So what I want to do, though, is focus on how we rearrange the formula if I want to make something else a subject. So let's say, how do we make H the subject? Of this formula. So the formula reads H equals something. There's a few ways you can think about doing it. The bottom line is the end result is always the same, but you might have your own way of rearranging formula, and I wouldn't want to tread on that in any way. If you've got a way that works for you for visualizing it, fine. But I want to have a look at how we might do this in a different couple of ways maybe, or sort of different ways of thinking about it. What I do is I look at the formula, P equals H rho G, and I've got to focus on the right hand side, this side here, the right hand side. I want H to be on its own, and then if H was on its own I would have a new formula to find H. So I need to get rid of these other two symbols, a rho and a G. Height, this number H, has been multiplied by the density and multiplied by G. So I need to sort of undo that effect. Some people think of it as undoing multiplied by rho. Some people think of just cancelling the rho out. But the end result is the same. If I want to get rid of rho, the number, it's a number, I divide by that rho, whatever that number is. And if I divide by that number, I can cancel it out. Equally, if I want to get rid of the G, I just divide by G, because it's multiply. If I divide by G, the opposite operation effectively, they cancel out. And you can see now that I'm just left with H. The trouble is, if I do that, I'll change the formula. So I need to remember that whatever I do to one side of the formula, I must do the same to the other. So if I'm going to divide the right-hand side by rho and G, I mustn't forget to divide the left-hand side by rho and G as well. So now I've got P over rho G equals H, because the rho and the G have now been cancelled out, and I've rearranged this formula to find H. I've made H the subject. So I write it with the subject first. That's traditional. So H equals P over rho G. And I've got a new formula. So I'll just pause that there if you want to make that note. So to recap, if I want to make H the subject, I've got to get rid of the rho and the G. How do I get rid of multiply by row, divide by row? But remember they're numbers. So if I have a number like, say, 4, and I multiply it by 3 to get 12, if I want to get back to the 4 again, I would obviously divide by 3. 4 times 3 divided by 3, effectively, times by 3 and divide by 3 cancel each other out, don't they? And we're left with the original 4. It's exactly that idea here, because remember, the letters stand for numbers. And that's what we're applying. To get rid of an effect, I do the opposite operation. So H has been multiplied by row, so divide by row to undo that operation. Here's another example. Very familiar formula to you. I want to rearrange that formula to make R the subject. So I look at the right hand side and I see that R has been multiplied by I. So what do? Divide by I to get rid of it. Okay? If I divide by I, what must I do to the other side? Right, the same thing. Whatever I do to one must do to the other to keep it balanced, effectively. So at this point, I's cancel, and I can see that on the right hand side I'm now just left with R. So V over I equals R. And again we'd write the subject first, and R equals V over I. So I've rearranged that formula for R. Right, here's another example. I equals P over V, and I want to make V the subject of the formula. This is quite an awkward one, because the thing I want to try and find is underneath. What I would do in this situation is I would actually, initially, multiply both sides by V to get V on the top on the other side. You had that idea. Good. So if I multiply both sides by V, then V's cancel on the right hand side, so I've not really got any closer to isolating V, but at least it's now on the top on the left hand side. So multiply both sides by V to get the V on the top, and then divide both sides by I to get rid of the I. So I've got now that VI equals P, and that's actually the more familiar form of this particular formula to find power. It's volts times current. But now I'm after V, so divide both sides by I, and I now have that the I's cancel. So V equals P over I. So that's a useful trick. If the thing that you're trying to isolate is underneath, often multiplying through by that will get it to the top on the other side. A formula that you will become familiar with, I hope, to find the final velocity given the initial velocity u, the acceleration a, and the t is the time. So they all represent numbers, the final speed, the initial speed, the acceleration as a number, and the time in seconds, say 30 seconds or something. So they're all numbers. At the moment it's set up to find v. I want to rearrange it to find u. So what have we got to do?
Divide A and P.
Divide, George? Take away, yeah. Because what's happened to you, I've added A and T, so subtract AT. I can think of this whole term, I can subtract a whole lot from both sides. So I effectively subtract AT from both sides. I wouldn't write this intermediate step, but I think you can see what's happening here. I've subtracted AT from both sides so that I've not changed the balance of the formula. But now, add AT minus AT, they cancel each other out. And so I'm just left with U. So the final formula is V minus UT, AT rather, equals U. Or writing the subject on the left, V minus AT. And I've rearranged that formula to find U. And the complications start when you've got combinations of addition and multiplication. So let's look at this same formula and rearrange it for A. I want to find the acceleration. The thing now is to think about the order of operations, this bid mass thing. So what do you think? Yeah, but what's happened to A? Look at A, focus on A. Now, yes, if we think about the right-hand side, what has happened to A? It's been multiplied by T, and then U has been added. So what do you think the first thing to get rid of is? Right. Yes, you subtract U, and then you divide by T. So, the first thing to do is to subtract U from both sides. It's got rid of the U on the right hand side, subtract U from the inside. Now divide by T. If I divide the right hand side by T, I'm just left with A because the T's cancel. But how do I write the left hand side? How do I show that I want to divide that by T? Yeah, line under both of them. V minus U all over T divided by T. So now A equals V minus U all over T. If I'd have done it the wrong way around, if I'd have divided by T first, it will still work. Let's look at it. If I divide by T first, I've got to beware of one thing. Look at this. 2 plus 3 equals 5. Right? If I want to now divide both sides by, actually let's change this and make the numbers easier because I don't want to overcomplicate it. Keep them all even. 2 plus 4 equals 6. If I want to divide both sides by 2, divide that by 2, note that I've got to divide every term by 2 for it to work. Look, 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3. It still is a balanced equation. So if I want to divide both sides by T, I've got to go V divided by T equals U divided by T plus A, because the T's cancel there. AT divided by T is just A. Now remember what I'm after, get an A on its own. So what do I do now? Take away UT, V over T minus U over T equals A. What can I do with the left hand side? Not cancel in this case, but because it's the common denominator, I can combine them and call it V minus U all over T, like we did in the drill, equals A. And so now we've got the same answer as we had in the other way. A equals V minus U over T. But I think you'll agree that to try and do it in that right order, in the reverse bid mass order, makes it easier. Okay? But I just wanted to show you that so long as you do the same thing to both sides and follow the rules of algebra and the rules of number, you will still get the right